Next speaker is Baoxin Teng, and he's going to talk about facilitating the application of GeoAI models through an interoperable model representation approach. He's also doubling up as our IT guru. So Baoxin, thank you very much.
Yeah, thank you. Yeah. Hello everyone. Today I'd like to share some working we are doing in OGC, and maybe we will push it this work also in ISO in the future. So as we all know that GeoAI technologies has been widely used in this domain. So I will not introduce it again because my colleague has introduced it. And we also have some similar tasks in geospatial domain. And I like to say that the sharing mode of geoinformation is changing. So in the past, we are using offline sharing, and we share data, the assets, and other services in a common interchange format standards. And later we use the online sharing of geospatial information services based on interoperability protocols. And in the future, we have the analyze ready data and analyze ready assets. We need to develop them from the general aspects to the AI specific data and services. So that means we need to have AI data and AI model and AI systems ready for use. So in the past, we have developed the training data markup language standard in OGC, and it is now under publication in ISO. And as well known that the models are the downstream task of the data. So we use the data to train, to validate, and we have models to predict based on this data. So we already have standards for training data. So we come to say that why not we have also we will also develop a standard to facilitate the usage of the model based using a standard. So that is the start point of our standards. So right now, people sharing and exchanging models during this process. So model developers, they create models and train them, and they publish them to some model sharing platform. The most famous would be the Hugging Face and GitHub. And model users can find models and download them, and they may need there will be an evaluation that they need to know if this model is trustworthy or it can be used. Is it applicable to my specific task? So and then they operate they do operation with it. So right now we have three public model description formats. So the PMML, the predictive model markup language, is proposed in the about 20 years ago, and it concentrates on the presentation of machine learning models. And for the model card, it is proposed by Microsoft and Google, and it uses free text to describe the model to facilitate the trustworthy model application. And for the stack, machine learning model extension. It is a specification developed in the stack community, and it uses the JSON encoding to represent the model and sharing models online. So these are three public model descriptions. But here we can see that they have some something they are not covered. For example, people may need to know that does the provenance of the model is good for me, and is this the quality of the model is it applicable to my task, and people will want to know if these models are applicable to my intended use. So so here comes the issues and the challenges. The first one is that because of the lack of transparency, it hinders the model. It hinders the trustworthy usage. So it not only means that people can. It is hard to know the architecture and the components within the model, but also means that it is hard to learn from the model itself that what happens in it, and is it works well or it is not applicable. So and the second issue is that the lack of the formalized description for GeoAI deep learning models. We have so many GeoAI models, but they are not formally described. And the third issue is that some of the specifications, for example, the model card, they are not machine readable. So if we just describe models using free text, it is good for human to understand them, but they are not applicable to spatial data in structures. So we have doing this work in OGC TDML Swig, and we start to design the metadata model in TDML Swig in 2023, and we are this March in the last member meeting, the TDML Swig members have a consensus that we can move all of this work to a new Swig, maybe the deep learning model Swig, so that we can attract more participation in the community. And we think that it is not mature to develop a standard to represent the models, but it is maybe it is a start point to describe the metadata for models. So next, I will give a brief introduction to it. And in remote sensing, we always have these tasks. So and people and scientists are using these platforms to sharing their models. So for users, they need to first find the model and access it locally so that they can use them. And they may evaluate the model based on the provenance of the model, the quality of the model, and the detailed intended use of the model. And then they need to deploy model locally. For example, they need to sometimes fight with the software dependencies and deploy them locally. And last is the operation part that they need to know the input and the output format and how to use them and the meaning of the hyperparameters. So model metadata is needed for all of these stages. So if without metadata, you cannot know the provenance, for example, where the model is, so what data is was used to train the model. And we come to these 6 key considerations. Firstly, we think it is good to align with the existing standards. For example, the standards published in ISO and IC42 and the existing OGC standards, for example, the training DML AI. And provenance is another important metadata. We need to know the detailed training process and who developed and trained the model and what data was used to train the model. And also, the quality is also important. It is so without quality, you cannot know. So if this is the best data, the best model for me, and compare different models. The intended uses, so it is recording the intended uses that were envisioned during model developing and training. For example, the applicable resolution, the applicable extent, so that you can know that it is applicable in China or in Africa. So and also the runtime metadata, it captures the deployment and usage methods so that anyone can run the model locally. And also some technical dependencies for professional scientists, that's professional readers, they can analyze the model from it as a quick list. Yeah. So and a conceptual model was proposed based on this. We have all of these components and it is similar to the training DML AI if you are familiar with it. And also a content model is developed based on the conceptual model. And we define the specific attributes in every component. And next step, we'll introduce one by one. So for the basic metadata, it leverages the geographic metadata from ISO 19115. And yeah, so for the provenance, we align with the W3C provenance model to describe the provenance for deep learning models. For deep learning models, it is important to know that the training procedure and the training data and who trained the model. So we described following the W3C provenance model. For model quality, it is hard to develop such a specification because we have model quality specifications from IC42 and also from geographic community, as well known as 19157. So at the start point, we use to keep alignment with existing geographic standards. We use the quality element to represent the quality of the model. So it uses mirror reference. It is an identifier, and the evaluation method, it describes the procedures and methods applied to the measurement, and we also have the quality result, so that the quality of models is alignment with other geographic data quality. So this is an example of how we describe quality for models. So for example, we have a land use classification model, and we measured it on a specific data set and using a specific metric. And then we can describe and encode it following the 19157. So it is comparable with other models. For intended uses, it was designed to be the detailed specification of the model that people can know from it the specific applicable tasks. For example, the specific applicable scenarios is object detection model can be used to remote sensing imagery or from CCTV imagery, and we can know that, or we can also know that the model is applicable to a specific resolution, and the extent if the model can be used to a city or a river and all the deserts. So this is intended use. For the runtime data, it is hard. It is also hard to develop such a specification because it is still under a rapid advancement. So we just define an abstract class that any other detailed runtime methods can be derived from this, and they can describe how to use the model and the format of the model input and how to leverage the model output. And we also developed the encoding rules for the model metadata. It uses a JSON encoding so that these metadata are machine readable. And this is a use case. We use the YOLO 11 small model, and it is an open source model. And it was trained on the DOTA dataset. Can be used to the object detection task. So following the model specification, so this metadata can be formalized in these components, and anyone who want to use the model and firstly you can find the model based on the name, the task, and the training data set it was trained on. And then it can be evaluated based on the provenance and the quality, and then it can be used following the runtime methods. So this is an encoding example, and all of this metadata can be encoded using the JSON, and so that they can be exchanged in a web environment. So in response to the current challenges in GeoAI, such as difficulties in model interoperability and concerns about the proper model application, this research proposes the deep learning model markup language to formulate and facilitate the model sharing and reusing. And we developed the conceptual model, the computer model, and also the encoding schema to facilitate the model usage. And future work, we will focus on the extension of model use cases, and also we will continue to advance the development of this specification in OCC. Thank you.
Thank you very much indeed. I think you've really hit on an issue here where there are a lot of models being produced, but actually describing for people to use, whether they've got the right one, and also issues of quality. So we've got time for maybe one question in the room. Does anyone have a question? Sorry.
First, great presentation. Good work.
Thank you.
Second, we had a discussion. You were in the room, I don't know, especially when I saw your comments.
The prominence.
Yeah, and what are your thoughts? Should the data, the prominence go back to the previous one?
Oh, previous one? Yeah.
Just previous slide. And whether that prominence should go back to the metadata. So,
Next, the previous one?
Next. The prominence slide and just the previous slide.
Prominence is
this one.
This one, yeah.
So when you have prominence, whether that can move into the previous slide, which was metadata. Yesterday we were having this discussion. So if you have any thoughts, because you know that I spoke to the data is under permission that people are ideas. And second, have you looked at the IEC AI quality? There's a IEC
IC42 model quality.
Quality, and how does that if it differs anyways?
Sorry, maybe I didn't get you. Yeah. So.
What I said was, if you have SOPC data, so model quality and data quality, how it compares to one of your proposing is it much?
Yeah. Okay. So firstly the assessment and the quality specification in ISO IC42. It is a specification mostly about the AI system and instead of the model quality. So it is a quality assessment of the AI system. So it includes many other characteristics. For example, the controllability, the accessibility, which is not so useful for the models. And the second problem is that it is not well, it is a good specification, but we should maybe we should compare. We should combine it with the existing geographic information standards. And this also happens to the quality of training data. Yeah, for training data, we also have a specification from IC42 and specification and standards from TC211. So maybe the coordination between them is one of the future work. Thank you.
Thank you very much indeed. Thank you. Okay.